This paper introduces ParaSolver, a hierarchical parallel sampling algorithm for diffusion models, which reformulates the sequential diffusion sampling process into a nonlinear equation system with a banded structure. Our experiments demonstrate that ParaSolver achieves up to 12.1 times speedup in wall clock time while maintaining comparable generation quality, setting a new state-of-the-art in this domain. We partition the time interval between 0 and t into n time subintervals. Considering the time subinterval begins from the nth time index at iteration k, with a sliding window of size p, the parallel iteration process begins with a set of initial guesses, which can be initialized using random noise or more precise approximations. The process then performs simultaneous sampling of all subproblems within the window, where each subproblem can be solved using existing parallel or sequential sampling methods, using the initial guesses from iteration k as starting points. The samples generated by solving the subproblems are then utilized to compute their drifts from the initial guesses. Afterwards, it updates the previous samples at iteration k by adding the drifts into a prefix sum. After the updating process, we get an array of new samples. Now, we need to check the discrepancy between the newly updated samples and the initial samples. If the error is below our adaptive tolerance, it has converged. Based on the index of the first unconvergent sample, we can determine the sliding stride of the window. Then, updating the states of iteration, such as initializing new sample points outside the current window and the iteration index k, we are able to prepare the input for the next iteration. Table 1 shows the experimental results on DDPM, DDIM, DPM Solver, and their parallel variants when combined with ParaDiGMS and our ParaSolver, respectively. ParaSolver demonstrates significant acceleration while maintaining comparable FID and CLIP scores. Notably, it achieves a remarkable wall clock time speedup of up to 8.1 times, setting a new benchmark for parallel diffusion methods. Similarly, ParaSolver consistently surpasses existing methods, delivering speed improvements of 2.2 times to 12.1 times on the L-Sun Church model across varying step configurations. Figure 2 shows the visual results when expediting DDPM with 100 steps. We can see that our ParaSolver significantly outperforms the competitors, with faster speed to generate a better image. Figure 3 shows the visual results when expediting DDIM with 100 steps. Figure 4 shows the visual results when expediting DPM Solver with 100 steps. Thank you for watching.